Alright, so in this video, I'm going to show you how to solve the Advanced Housing Price Regression problem. Now this is a Kaggle competition and it's perfect for those who are just getting started on data science as you get to work with a lot of feature variables. Now I'm going to be showing you the entire project itself from start to finish, and rather than just typing up the code myself, I will be making sure to explain you each and every single line that I've written already. Now with that said, let me just take you to the overview page of the competition itself. Alright, so here I am in the main page of the competition itself, the Kaggle competition. I'll make sure to link this down in the description box below. And over here, what you have to understand is we will have to basically predict the housing prices based upon some given variables. And for this case, and since this is Advanced Regression Techniques, as the name suggests, we're going to have 79 explanatory variables describing each and every aspect that we will need to make predictions. Right? So as I get to the data tab, here they have given us the information of the files that we're going to be downloading. There will be a training set, test set, and then there's some sample submission CSV file as well. And then they have given us information of each and every single column or the feature that we have. So if you're going to spend 3 to 5 hours on this project, this is what I would recommend you to do. Just understand each and every single column and try to create some interesting features with these. That is, just perform extensive feature engineering and then take it to the next level in terms of predictions as well. But for our case, in this video, just for the sake of simplicity, I'm going to deal with the none values, just perform basic data analysis and manipulation, and then go to prediction directly. Alright, so here we've got information of every single column, and then we have the actual visualization of the data itself. This you will only get to see once you join the competition. So when you click on join competition, it's going to ask you for confirmation, and as you do this, you will be able to be a part of this competition. Right, once you do that, it will refresh, and then you can go down to the data tab once again, and then now you'll be able to see the sample of the trained CSV itself. Now, there is only one thing that is not going to be present in the test CSV, that is going to be the sale price. This is the one that we have to find ourselves. I don't think so it's available here. You just have to find the sale price column. Alright, now this is not going to be available in the test set, because that is the one that we have to predict and then give it as a submission. And they've also given us a sample submission CSV file, the things that they're expecting. They expect a sales price column, and then they also expect an ID. Alright, so after we've gone through all this, just click on download all. That will give you a zip file. You will extract it to a specific folder. Now, I have come to my VS Code, and this is my Jupyter notebook. Here I've written all of the code down. I'll be explaining it line by line. But basically, after extracting all of those 4 files to a specific folder, I recommend you create your Python file in that same folder. I've set the index to ID because that is going to have every single unique value. Now when you run this code cell, that's going to create our main data frame, and then when you type in df.head, as you see over here, we get our first 5 records of the dataset itself. Now here we have set the ID as the index, so that pops up a little bit down, and then it shows 80 columns, 79 features, the sales price column, and the ID. Alright, so after that is done, the next thing that I'm going to do is find all of the none value columns. That is basically, if a specific column contains none value, then I will extract it and put it inside a new data frame. Alright, so let me show you what I mean. So this statement writes here, I just want you to look at the one that I'm highlighting right now. Now this basically means this will show us all of the none values in each and every single column. And I'm setting a condition that if it is greater than 0, that if at least one none value is present in a specific column, this will show each and every single none value. Again, let me just show that. df.isNA.sum, and when you just run this code cell, you have to put in like that. Alright, now it shows that each and every single column, the amount of none value is present. Now if it is 0, then we're not worried about it. So I've set in a condition that if it's greater than 0. So let me just show you what happens when I do this. I do this, it gives us a true or false value, a conditional value, just like a mask. And I'm going to do that, put that inside of the slicing condition, and do the same comment once again. So this time, we're going to get all of the columns. Actually, let me just copy this and show you. All of the columns which contains at least one none value. So when I paste this and run this code cell, I'm going to get all of the columns that contains at least one none value. That is what we're going after. And this only displays the none values in each and every single column. What I want is the index of that. So I'm going to retrieve the index and then extract that from our data frame and store it in a data frame called df null. Alright, so now when I run this code cell specifically and then do this, we're going to see the 34 columns that contain the none value, and those will pop up right around here. Alright, And then now I'm going to check the heat map, that is the amount of none values. This will give us a good understanding of the none values present in each and every single column of the df null. So when I run this, it gives us the exact heat map that you just saw. And as you see over here, let's take the ally column for example. There is just too many none values, and so is for the pool QC. So we can safely remove all of these columns where all of the none values are just extensively high. Alright, so what I've done here, I've gone on ahead and created another data frame, and it's called df objects. Alright, what I mean by objects is all of the columns that contain only just string values or other values that is not numbers. For example, this doesn't come under object, this comes under float. Alright, but this comes under object and this comes under object. So I'm going to create a data frame which contains all of these object columns alone. And the way I'm going to do this is by using the df.select dtypes function, and then I'm going to include only the object data type. We retrieve all of the columns out of it and then put that inside the df entirely and then store it in a data frame objects. Alright, now so this does mean that I'm first dealing with the none values of the objects column, that is I'm dealing with the none values in the columns which are only objects, and right over there I have just done the same thing what I've done over here. Like basically just setting the condition to more than 0. That is, I've set the condition over here to 1100. That is, if there is 1100 none values, then it's not going to give us much of a value, so I'm just going to drop it directly. Alright, so use the df.isNA.sum and then mention the condition just like a mask, retrieve the index just like we did above, and then retrieve all of those columns, mention access equal to 1 as you do df.drop. Alright, hopefully that makes sense. So we have created df objects, and then I have also dropped off all of the columns in the objects where the none values is just greater than 1100. So let's just run this code cell. Perfect, that is done. Alright, I've done the same thing. This is done on the main data frame. I've done the same thing on the df objects data frame, just basically removing all of the columns where the none values is just greater than 1100. And then we are going to fill NA values. Alright, so basically now our df objects, let me just actually cut this and type in df objects.head to show you. .head, and you run this code cell. Now this objects data frame will contain only those columns where the none values are just less than 1100. That is, we can at least get some value out of it. So those are the columns that we have in this df objects dataset. And what I'm going to do here, let me just paste that once again. In those columns, I'm just going to fill all of the none values. And what I mean by that is, let me just see if I can find some. Nothing. All right. So I'm going to fill all of the none values by a string named null. Let me just show you why I do this. All right. So let's say I take this utilities column, for example. All right. So I'm going to access those utility columns, and then when I type in value counts and then come over here and see, there is only 2 categories of values in this utilities column. It's either all PUB or no saver. And no saver is just 1 value. And apart from this, there might be none values in this utilities column. So what I've done over here is actually, let me just cut this and run this code so I'll show you. What I've done over here is fill all of those none values. Let me just do that and come over here and do this. And now we see that we have a new category, null category. So now we will have 3 different categories. And why did I create this category? Is because I'm going to do one hot encoding. So basically what this means is, like right as you see over here, the utilities column will have 3 different types of values. It's either all PUB or null or saver. So what I will do is create 3 new columns for each and every single record. And for that specific record, if they belong to all pub category, then off of those all pub, null and saver, all pub will have 1 and then null will have 0, no saver will have 0. But then if the null value is true, that is if null seems to be the category for a specific record, then null will be 1 and the other 2 will be 0. And this is known as one hot encoding. You can just directly do that by using the getDummies function in pandas. Alright, you just have to pass in the data frame, and that will create a specific new data frame. I'm just going to call that df objects.encoded. So let me just run this code cell once again. And after I've done that, I'm going to come over here. Alright, before we get to this code cell, let me just type in df encoded objects encoded dot head. I just want to show you the first 5 records of the encoded objects. Alright, so right as I see over here, we've got 247 columns, and it creates different categories for MS zoning. Like MS zoning might have, in fact, let's just go ahead and type in
MS zoning. And then as we see, there is 5 different categories, right? Including null, it's 6 different categories, and that's what is created here. So for the first record, if it belongs to the RL category, then RL will be true, but then all other everything else in terms of MS zoning is 0. So now we have 6 new columns out of this MS zoning column alone, and that's what I've done here with every single column in the DF objects. Right, so that's how you deal with it. And then what I've done here is I want you to notice this column over here, this MS zoning null. Only if other 5 of them are false, then this one will be true. And we don't have to extensively mention this to the model while training. So what I've done is I have deleted all of these null categories columns. So what I've done here is gone on ahead and looped over the entire encoded data frame columns. And then if null is present in those columns, then what I've done here is just dropped off those null column mentioning access is equal to 1, and I've also made sure that I'm printing it. So when you run this code cell, you're going to see all of the dropped off column and it all has got null. So you don't have to extensively mention this to the model, but if you do wish to do that, it's actually okay to do so. Alright, so this is kind of an optional step, and I've done this. The new data frame that I've created over here, this is the new DF, and over here it has got 304 columns, and I only want the columns which are not objects because we have dealt with it and we have created too many Boolean columns as well. So what I've done is access the main data frame object columns and then drop that off from the new data frame. And then now I have set the condition once again, checking for null values in each and every single column, and if it turns out to be true, these are the ones. So basically what we have done here is our new data frame contains only numerical columns, that is the columns which only contain numerical values. It's either 1, 0 or any floating point numbers. So those are the columns that we have, and over there we have got so many none values in these columns. So we have to deal with all of these. And what I've done over here is, again, let's just run this code cell. And what I've done over here is created 2 new lists. I've named it mode columns and mean columns. This basically means I've created a list of columns for which I'm going to fill all of the none values with just mode. That is, I'm going to find the mode of those columns and use it to fill the none values. Alright, and then when it comes to mean columns, I'm just going to find the mean value of a specific column to fill in the none values for that. The way I've decided if I want to find the mode or if I want to find the mean is by just looking at the column, house prices, and then go to the data to look for a specific column and then see what kind of definition have they given. For example, in our case, let me just go ahead and see for garage cars. So to show you, alright, so garage cars have the size of garage in the car capacity. So that means that we can't find a specific mean value for this. What I've done here is gone on ahead and I'm just going to decide that I will have mode values for this. So that's how I've decided for each and every single column that goes under mode and the mean. Alright, so just looking at the columns, trying to identify what it means. Alright, and then I have looped over all of the columns, and every single columns I have used the fill NA function. That is just, again, you just have to see that new df of I am again accessing it with the fill NA function and then finding the mode of it. Just make sure that you're accessing the 0th element, that only gives you the mode. And similarly, I have done that over here as well. I've just used the numpy round function, just making sure that I don't get a floating point number, and finding the mean for each and every single column to fill in the none values over there. Alright, now when I put in this condition, it should not give us any columns and it gives us an empty list. So there is no none values whatsoever inside of our entire data set. And I've called this the new DF. So the final data frame that we have after performing pre-processing is new DF. Now, try to remember that I've split the training data, that I've merged the training data and the testing data together before performing any type of exploratory data analysis. So now it's time for us to again split them up into DF1 and DF2, and I'm calling this the testing data and the training data. The training data will be the len of DF1. That is, it's going to start from 0 and then find the length of DF1 and then get the exact length of all of those and put that in the training data. And onwards, that is from the length of DF1 till the end will be the testing data, because remember that we have vertically stacked the training data and the testing data. So on top of the testing data is going to be the training data. So the first initial set of columns will be of DF1, and then from DF1 till the end will be to the testing data, that is DF2. Alright, now our testing data, we don't need the sales price column anymore, so I'm going to drop that off as well. Alright, so let's just run this. And now we come to the model training section. Alright, here we specifically select a few algorithmic models and then train the model based on the given data. and then we decide how the model performs based upon some metrics, and then we will go on ahead to create a submission CSV file and give it and submit it on the competition. So here a lot of imports are happening, and the first dependency that I'm going to show you is the train test split. This will split the data. Let's say I'm taking the training data over here. I want to split this into train and validation. I will be providing around 80% of the data to train the model, and then 20% of this training data, because we have the labels for these training data, to test the model on the training data itself. That is the rest of the training data. I'm going to call that validation set. All right, and then I have imported metrics mean squared error. This is the metric that I will be using to see how well a model is performing or how dumb a model is performing. All right, you can choose any other metric as well. There is F2 score, there is many others. So I've just gone on ahead with the mean square error for simplicity. And then I'm going to be using 3 different models and see which one performs the best. All right, so I've gone on ahead to import the linear regression from the linear model. There's also polynomial regression you could try out, which I recommend you to do so. And then from XGBoost, this one turns out to be my favorite. From XGBoost, this is just gradient boosting. Again, just make sure to pip install XGBoost. So go to your terminal and type in pip install. That will install the XGBoost algorithm, where it's got XGBoost regressor and the XGBoost classifier as well. We have talked about that in our previous video. And then I have also gone on ahead from scikit-learn and Subble. I have imported a random forest regressor. There is also a random forest classifier which you could do for classification tasks. All right, so import all of these, and once that is done, now I'm going to split the training data. All right, so I will be dropping off the sales price column just temporarily, just to set this as the training data, and then the output label, Y label, will be the training data's sales price. All right, now here I haven't mentioned in place equal to true, so this is not going to just directly delete the sales price column off of the training data, but then it will extract that out of it and then put everything else in terms of X. And then as I'm accessing it on the Y label, it stores that on the Y. All right, and then I have created X-train, X-test, Y-train, and Y-test. And this X-test and Y-test will be out of our main training data only. See, as I want you to notice over here, we've created X and Y. All right. We've used the train test split function. You pass an X, Y label, and then you want to mention the test size, that is the validation size. If you mention 0.2, that means that you will get 20% of your entire data for testing. All right, so X-train will contain 80% of X, and Y-train will contain 80% of Y, and the rest goes on to X-test and Y-test. And then I have used the reshape function, because generally when you see Y-train's shape before doing this step, it's just going to be a one-dimensional rather than being two-dimensional. And our model expects always a two-dimensional array in terms of understanding data. So I've done that for Y-train, and then I've also done that for Y-test. And then now when I run this code cell, if I type in xtrain.shape and ytrain.shape, it gives us this shape, and then we want it to be two-dimensional and make sure that the number of records match. All right, this one basically means the output value that we're trying to predict. All right, so the first model that I'm going to have is linear regression. We have imported that above, and then you just have to type in, actually first, as you define the model, the basic format is always going to be to define that model and then use the fit function and then use the .predict function. All right, so first you create the linear regression model and then you pass in X and Y. Of course, you could pass in the X train and the Y train, but we also have a specific testing data, which is what we're going to try to predict on. So what I've done here, you could try out the X train and the Y train, which I actually did, and then see how the model performs on the test set. So let's just try that, put that X train and Y train, and then run this code cell. We have to put this in capital. Now we get a pretty high mean squared error when I compare that to our model 2. Now model 2 has a few hyperparameters. First thing is going to be n estimators. How many estimators do you want in terms of gradient boosting? And then you also want to mention the learning rate. Again, and random state is an optional step. Let me just remove that to set a random seed. I'm going to have that. Learning rate is basically how fast do you want to take the next step in terms of learning. Again, if you're familiar with the gradient boosting algorithm directly, then you will understand what learning rate is. So basically, you just have to mention two parameters, two hyperparameters as you mentioned. You create XGB regressor and then use the model.fit. Again, pass in the train data first to see how the model is performing over there. Capital Y, train. All right. And then see the predictions for the X test, that is the 20% of our training data. you use the mean square error function. You first pass in the actual label, and then you also pass in the prediction label, which is we made over here. Model2.predict actually does that. Right, as we see over here, the model actually performs better than the linear regression model itself directly, but again, this gives us a very high value. So as I try for the random forest regressor, again, you have to mention the number of estimators that you want in terms of this algorithm. And as you get the regressor function, again, you just perform the same steps and see how the model is performing over here. Again, just make sure to put in train, right? Make a prediction. Alright, now we get the random forest mean square error as well, and this seems to be higher than the XGB regressor. And in terms of mean square error, we want to make sure that the number that we get is always lesser. So this model turns out to be better than the other two that we've decided. So what I'm going to do now is just, rather than giving the train set alone, I'm just going to give the entire training data set, because we want our model to train on this, and then now see how the model is performing. Again, we see that the values drop, the mean square error values drop significantly. That's because we are giving in the entire data. I'm just going to do the same thing for our second model, that is XGB regressor, and then run this console. Alright, and here as well, we see the value drop off significantly, and then I'm just also going to do that for random forest, because we just have to provide in the entire data set in terms of training to train our model perfectly, and we make predictions on the testing data alone. And what I mean by testing data is this one, and what I mean by X test or Y test is the test set that we created from our training data. Alright, so as I see over here, once the model is done training, we get the mean square error, and again this value does drop off, but again it seems to be very high. So when you compare this to other two, XGB regressor does significantly better. So that's the model that I'm going to take to make predictions. And also, this is just for visualization. You don't have to actually understand this. This is kind of an optional step. You could do any type of visualization as you wish. I'm just going to delete this. And I have selected model 2, as I saw it has the lowest mean square error. And then I have used the predict function, passed in the testing data to get predictions. And I want you to remember the sample submission CSV file. In fact, let me just go over there. Our sample submission CSV file should contain the ID and then the specific sales price that we are predicting. Alright, so I'm just going to go over here, and then to get the index or the ID itself, the testing data.index, that is our final ID, because since we have set the index initially to ID over here in the very first line, in the very first cell of our data analysis, we have set the index as ID. So this column will be set as our index, and right as we split that over here, we can just directly access that index. That index will be the ID column from the testing data, and then I've called that column as ID. So first, after creating an empty data frame and calling it final, the final of ID, that is creating a new column ID, I have set that with the index, and then I've made predictions accordingly with the testing data and set that as the sales price column. Now, we don't need a specific index column, we have the ID itself. So we have to mention index equal to false when you're typing in final to CSV, that is, it creates a CSV file. I've just called that output.csv, and then you don't need a specific index. So when you run this code cell, it's going to create an output CSV file. As I open it, we get only two columns, ID and sales price. Whereas when you don't mention this, let me just show you what happens. Run this code cell once again, and go over here, just do this. Now we get another additional column, which is the index, which is not what we need. So I'm just going to close this and make sure that I type in index equal to false, like that, and run this code cell once again. So now we have an output CSV file which we can submit for prediction. And the way you have to do this is go to your home page of the competition itself, and over here just click on submit prediction and navigate through to your folder where you have the Python file, and then from there you can just select the output CSV file. In fact, let me just do that quickly. The output CSV file, I'm just going to drag and drop that over here, and then click on submit. And there we go, our submission is successful. We've got a score, and this score has to be as low as possible. So when I go to my leaderboard, and then when we jump to our position, it puts us at 1458, which is pretty decent, and we got many others at the same number as well, and the number goes down further as well. So you want to make sure that you have minimum amount of error. If you can achieve this type of error, that is actually really nice. And if you wish to do that, and what I recommend you to do so is just go over here and identify and understand every single data column and trying to create feature engineering and trying to just manipulate the data much more. It's all about manipulating the data rather than finding a perfect model or an algorithm. Alright, so Alright, up next in this Kaggle competition series, you're going to be getting our hands-on computer vision. You're going to be building many different image classification projects. So as I go to competitions, once the competition is done, we're going to get to the standard M&IST dataset, the digit recognizer. I'm going to teach you the basic format of computer vision, and if that is released, I'm just going to link it up on the screen. And if not, you can also watch our previous video which looks onto the Spaceship Titanic competition. This is a classification competition, and I teach you a specific tool which you could use extensively when it comes to dealing with none values. It's just very efficient in terms of time and in terms of performance as well. So I will link that over here onto your screen.